Hello everyone, welcome back to Tanisha's Concept Corner. In mathematics, we were doing the chapter matrices, and in our previous class, we have completed the first exercise. So today, let us start with the new topic operation on matrices. First thing is addition. The only point we must remember while adding two matrices is that their order should be same. That is the number of rows and number of columns. Here, if we see, we have 3 rows and 2 columns. In this matrix also, we have 3 rows and 2 columns. So we will be able to add these two matrices by adding the corresponding elements like 80 plus 90, 60 plus 50, 75 plus 70 and so on. And then we will be able to get the final result. So this new matrix is the sum of the above two matrices, and we have to always ensure that the number of rows and number of columns will be equal. That is the only thing. Now here one example question is given. If we see over here, we are having 2 rows and 3 columns. Here also we are having 2 rows and 3 columns. Because their order is same, we will be able to add both the matrices. If you want to add them, just add the corresponding elements. 2 plus root 3, 1 plus root 5, 1 and minus 1 you're going to add. Then 2 minus 2, 3 plus 3, 0 plus 1 by 2. And then you'll be able to get the required answer. So if A and B are of not same the order, then A plus B is not at all defined. You won't be able to add the two matrices. If you see over here, we have 2 rows and 2 columns, 2 rows and 3 columns. Order is not same, then you won't be able to add the matrices. Now multiplication of a matrix by a scalar. We are not multiplying two matrices over here. We are multiplying one particular matrix with any number. Then how do we multiply? That is also really simple. If you have to multiply any number, simply multiply it with every single element in the matrix. Suppose this is a matrix A and they say you to find what is 2A. Now they are not asking to multiply any two matrices because A is a matrix but 2 is just a number. So how do we multiply? Just multiply 2 with every single number, then you'll get 2A. So that's the only thing over here. And yes, generally, when it comes to matrices, we say that subtraction is something that is not defined. We don't directly subtract. So, a way of writing the subtraction is actually like this. So, if you have to find the difference of matrices, all you have to do is write it in this format: A plus minus 1 into B, that is nothing but A minus B. So we write it in this format, and minus 1 into B is nothing but a scalar multiplication. So whenever you have to find like a difference between two matrices, A minus B, then take the matrix B and simply multiply every element of it with minus 1. And whatever matrix you're getting, add it with A. So if you want minus A, you will just multiply this with the negative 1. So minus 3 minus 1. Minus into minus is positive. You get positive 5 and then you get the minus x. So that is all it is about. Now they're asking you to find 2a minus b. Like this kind of questions will be given. So this is nothing but a scalar multiplication. So you multiply 2 with a first. And then you have to simply multiply a negative sign with b, so that you will get minus b. And simply add both the matrices. So here that's what they are doing. 2a minus b, multiply 2 with matrix A, 2 1s are 2, 2 2s are 4, 2 3s are 6, like that every single element. Then negative sign to be multiplied towards b. So 3 will become minus 3, minus 1 will become positive 1, again 3 will become minus 3 and so on. Then add the two matrices, you will get your required answer. Now properties when it comes to addition. Commutative law, a plus b, b plus a, they both will be equal. The normal number system also, this law used to be applied. And associative law also, if you take brackets also, a plus b plus c, either add these two matrices first and then add c, otherwise add b plus c first and then add a. There won't be any difference, you will get the same result. Then additive identity, this is important. This is basically O is a matrix that is nothing but zero matrix, where all the elements are 0. So take any matrix, for example A can be any matrix with the same order. If you take a null matrix, suppose A is 2 cross 2 matrix, any numbers can be there in that. Now take a null matrix, 2 cross 2 matrix only, all the elements are 0. add both of them. Basically, you will be adding the corresponding elements of each. What will you get? You will get A only. This is nothing but additive identity. It's just like saying in normal number system, if you take 5, then add 0, you will get 5 itself. So 0 is the additive identity. Similarly, in terms of matrices, you will say 0 matrix, not just one number. Then additive inverse is same thing we did for difference, basically multiplying -1 to any of the matrix. And then if you're going to add this, like there is a matrix, if you want the inverse of it, in case of addition, you have to multiply negative sign with it. Now if you're going to take the addition, you will get the additive identity, basically taking 5 as a number, then multiply it with negative sign -5. If you're going to add those both, 5 minus 5 is 0. 0 is the additive identity. Same thing, but just difference is that this is in terms of matrices. Now further, we have properties of scalar multiplication, basically where you're multiplying a number. So K is a scalar. So suppose two matrices are given. Either add those both matrices and then multiply your number, whatever you have to, or otherwise multiply this number to this matrix and then this matrix and then take their addition. Anything will be fine. Similarly, if there are two scalar quantities and one matrix, what can you do? You can add those both scalar quantities and then multiply A, or otherwise first multiply one scalar to one matrix, then other scalar to other matrix, and then add them. So either way it is fine. Now we have to find the matrix X. X is some matrix. We know the value of A and B. If we have to find X, what will we do? So first 2A is given, so multiply 2 with all of these. Then 5B, you will multiply 5B, so multiply 5 number with this B. If you want to get 3X, you have to do either send this 2A towards this side, so that it will be 5B minus 2A. And to get X, basically you have to send this 3 also, it will come into division. So that's what they have done over here. So they have sent 5B is here, they have sent 2A towards this side, so 5B minus 2A, and 3 is left out because it's in multiplication, it will come into division. Now you know A and B values, so simply substitute B matrix, A matrix, you're going to multiply them. 5 2s are 10, 5 2s are a minus sign is there, so minus 10. Multiply all the numbers, then multiply -2 with all the numbers so that you can take the addition of those both. After taking the addition of those both, you're going to get this -6, -10, 12, 14. Now you have to divide every element by 3. Actually in matrices, if you have to divide also, division of two matrices is not allowed. This still counts as a scalar matrix, scalar multiplication only, where 1 by 3 is being multiplied to -6, -10 like that. And if they are giving any two matrices, you cannot divide those two matrices. That is not defined over here. So if you're going to multiply 1 by 3 to -6, -10, you will be able to write it. You can leave it in fraction and that will be your answer. Now over here, a different kind of question is given where there is two matrices. You're going to add them, you're going to get this. If you're going to subtract them, you're going to get this. They did not give X and Y values, you have to find them. Same like our number system, same like our linear equations only. Only thing is that they're matrices. Obviously now you are able to see here plus Y is there, minus Y is there. First instinct is to add these both equations so that Y and Y will get cancelled and you will be left with 2X. So 2X, and the right hand side also should be added. So add them, 5 plus 3, 6 plus 2, 0 plus 0, 9 minus 1. Now you will get this. Now simply take this towards this side, 1 by 2 it will become. And then normal scalar multiplication only, 1 by 2 into 8 is 4, 1 by 2 into 8 is 4. You will get this matrix, you got X. Now Y you have to find, meaning you know X plus Y is 5209. So X you got. What should be Y? You can subtract 5209 minus 4404. Over here actually they're again subtracting and doing 2y and then calculating, but you already got the X value, so you can directly substitute in this particular equation. X plus Y is equal to, so 5209 minus the X value is 4404. So 5 minus 4 is 1, then 2 minus 4 will be -2, same value we will be getting. 0 minus 0, 9 minus 4 is 5. So by value we can get like that. So first find one variable, then substitute that and find the other variable. Now find the values of x and y from the following equations. Now we have to find the elements, not the matrix itself. So again we will follow the normal rules that we know itself. 2 into this is given scalar multiplication, multiply it. 2x, 10, 14, 2 into y minus 3 will be 2y minus 6. Plus this matrix is equal to this matrix is as it is. Now send this matrix towards this side. It will be subtraction because here it is positive. So if you send it over to that side, so what will happen? 7 minus 3, 4, then 6 minus of minus 4, 10, 15 minus 1, 14, 14 minus 2, 12. So after sending this, you have subtracted and you got it. So it will be something like this. After subtraction, you got this, and LHS side, this is there. Now remember, equality of matrices, what we used to do? We used to simply equate the corresponding elements. So 2x will be equal to what? 4. Then x is 2. 2y minus 6 is equal to 12. Corresponding elements. So 6 you send it to the right hand side, what will happen? 12 plus 6, 18. Then 2y is there. 2y is equal to 18. Then y will be 18 divided by 2. That is nothing but 9. So this is how we solve this question. So x is basically 2 and y is basically 9. Otherwise you can simply add these two matrices also because the order is same. So simply add 2x plus 3, 10 minus 4 is 6, 14 plus 1 is 15, 2y minus 6 plus 2. All this you can do. That's what they have done over here. They have added these and then equated. Either way it is fine. Now the next question says that two farmers, Ramkishan and Gurcharan Singh, cultivates only 3 varieties of rice, namely Basmati, Permal and Naura. The sale in rupees of these varieties of rice by both the farmers in the month of September and October are given by the following matrices. So in September what is the sales, and in October for how much rupees the sales are, they have given by Ramkishan and Gurcharan Singh. So now they're asking, find the combined sales in September and October for each farmers in each variety. So there is these varieties and each farmer. Now they're asking for combined sales for September and October. What are we supposed to do? We are simply supposed to add the two matrices. So if you see, they have added A plus B and they have got the result. So 10,000 plus 5,000, they have got the 15,000. Then 20,000 plus 10,000, they have got 30,000. Simply they have added and just mention that particular farmer. So for this farmer, this row will be considered. For this farmer, this row will be considered. And each column is representing the type of the rice. Next, find the decrease in sales from September to October. So there are decrease in a particular kind of variety, there is a decrease in particular kind of variety, there might be increase. But yeah, basically from September to October, if you have to find the decrease, simply we have to subtract both the matrices. So A minus B we are going to do, and we will be able to get the decrease. If you see over here, 10,000 minus 5,000, 5,000. So like that, each corresponding element you subtract and write. Then next question, if both farmers receive 2% profit on gross sales, compute the profit for each farmer and for each variety sold in October. Only for October sales they are asking 2% profit. So simply take 2% of this, 2 by 100. It will be scalar multiplication only. So 2 by 100 into B, 0.02 into B. So we can just simply multiply this and we will be able to get the answer. 2 by 100 into 5,000, 2 zeros will be cancelled out. Then 2 into 50 is 100. So just a scalar multiplication, just multiply it with every particular element. And they have written how much profit each farmer is receiving. Because for Ramkishan it is 100, 200 and 120 for the particular type of rice, and for Gurcharan Singh also 400, 200, 200 is what profit they are receiving respectively. Now we are doing multiplication of matrices, where two matrix we will be multiplying, not a scalar multiplication. We are not multiplying a number to a matrix. So that is the difference over here. So how do we multiply? We can multiply based on one condition. For addition, for subtraction, the only thing that we were talking about was that their order should be same. For multiplication also there is some condition like that, but it's slightly different. Whatever columns are there in the first matrix, for example, let's take an example over here, 2 4. So this is 2 by 2 matrix. Now I will take example like 2 1 3 4 1 5. What is the order of this? 2 rows and 3 columns. So if you have to multiply two matrices, not compulsory that their entire order should be same, the rows and columns. Only the column of the first matrix should be equal to the rows of the second matrix. Don't change this order, column of this to this row. No. Column of the first matrix should be equal to the rows of the second matrix. Then only you will be able to multiply. Then only multiplication will be defined. So from this we can get the particular interesting insight is that if this is A and if this is B, if AB is possible, maybe BA is not possible, because I have defined it in such a way. Columns of the first matrix. Because I'm multiplying AB, I can say, but what if I'm multiplying BA? Then B will become the first matrix. Column of the first matrix should be equal to the row of the second matrix. 3 and 2 are not equal. So BA is not defined. So this multiplication of matrices is not like a normal multiplication of number where you can say that okay, if A into B is there, then it will be equal to B into A. If A into B is possible, then B into A also should be possible. No. If AB is possible, it is not compulsory that BA is possible. And if AB and BA both are possible, it doesn't mean that always AB will be equal to BA. We will see that because the multiplication is just not like a corresponding element you are multiplying. It goes by row by column. Okay, so understood this first rule. If they give any two matrices and they're telling you to multiply, first thing you would have to check is whatever first matrix they have given its column and second matrix they have given the row, are they equal or not? Then only you will multiply. Otherwise you'll simply say AB is not defined. Now how do we multiply? We will multiply row by column. What is that? Take the row of the first column, take the row of the first matrix, take the first column of the second matrix. Now if you multiply 2 into 2, that is 4, then 4 into 4, that is 16, plus 16 you have to do. This will give you the first element. This is the first element. Now to get the second element, one more thing. After multiplying, you will be directly able to tell what will be the order of after multiplication also. Whatever left out numbers are there, no, you have to get 2 cross 3. 2 rows, 3 columns you will get after multiplication. So if they're going to give you any two matrices, they have given its order and they're telling after multiplying what will be the order of the matrix that you're going to get as a product. You no need to multiply and check. You can directly check, okay, columns are equal to rows. Whatever left out, that will be the order of the product. So 2 cross 3 is the order that we have to get now. Now get the second element. How will you get the second element? Same row, but go to the second column now. This column you will go. This particular column, same row. 2 into 1 is 2. 4 into 1 is 4. Add these both. This will be the second element. Now again, this particular row and the last column that we have. 2 3s are 6. 5 4s are 20. Add that. Okay, first row is done. We need to get 2 rows. Let's move to the second row. Now this particular row you will consider, and same thing, you will multiply it with 1 1 column to get 1 1 element. 6 2s are 12. 4 2s are 8. Add those both. You got this element. Now for next element, multiply this row to the second column. 6 ones are 6, 2 ones are 2. Add those both. 6 threes are 18, 5 twos are 10. Now check whatever matrix you got. Is it 2 cross 3? We have 2 rows and we have 3 columns. Yes, that is correct. Now simply add all these. Then you will get 16 plus 4 will be 20. 4 plus 2 is 6. Then we have 26. 28 and 28. That's it. This is how you multiply two matrices. So always go first row, first column, then whatever columns are there, row by column multiplication, and check the columns and the rows. So now let us get back over here. That is what they're explaining over here, basically how do we multiply, and they have given this theory. See here, n and n. Basically the column of this A is equal to the rows of the B, and you have to get the answer in m cross p order of the matrix of the product, and you're going to multiply the first row with the first column and simply add. So if you see the product order is m cross p, because that's the one that is left out over here. Now they are telling how to multiply one particular row, then column, then that row and second column. You will be adding to get the elements. Now here example question is given. A is this, B is this. They're asking AB. First check the rule if this column is equal to the rows or not. How many columns we are having over here? We are having 2 columns. Here how many rows we are having? We are having 2 rows. So yes, we will be able to multiply. So we will go by row by column. So first 6 twos are 12, then 9 into 7. We have to add those both to get the first element. Now the same row but the different column. 6 6 are 36, 9 9s are 81. Add those both. Then again 6 zeros are, then 9 into 8 you will add. After getting the first row, you will go to the second row. Second row, again first column, second column and third column. Because this is 2 cross 2 and this is 2 cross 3, and we know 2 and 3 are equal. So we have to get the left out one is 2 and over here 3. So 2 rows and 3 columns should be the product. Same like this example only. 2 cross 3 should be the answer. So simply add, you will get the product. Now this is the important thing that I've already said. If AB is defined, that means the column of A is equal to the rows of B. Not necessarily that BA will also be defined, but it will be only defined. For example, A is M cross N, B is K cross L. For example, some order is given. If N is equal to K, L is also equal to M, then you can say, okay, AB, BA, both are defined. Still don't know if they're equal or not. And they will be like AB and BA both will be defined if they're square matrices of the same order, isn't it? If I take square matrices, number of rows should be equal to number of columns. I am telling both the matrices should be square matrices, same order should be there. If this is 2 cross 2, this also should be 2 cross 2. Both are square matrix, both order is same. This column is equal to this rows, this column is equal to this rows. So AB and BA both will be defined if there is a square matrix, or if you are able to see M cross and K cross L, N will be equal to K, L will be equal to M, then also you can say both are defined, both are existing. Now again, it is not necessary that AB will be equal to BA. So we will see that. AB, if we have to calculate, we are having how many columns here? 3 columns and 3 rows. Yes, so we'll be able to multiply. So take this particular row and this particular column. Multiply 1 into 2 minus 2 into 4, 3 into 2. That will be our first element. Then again 1 into 3 minus 2 into 5 minus 10. Then 3 ones are 3. So add those all, you will get the second element. Then again take the second row, first column, then second row, second column. You'll finally get this. This is our AB. Now let us try and find BA. Here BA is also defined actually, because here if you see the order is 2 rows and 3 columns. We are having 2 rows and 3 columns, and for the second matrix we are having 3 rows and 2 columns. 3 rows and 2 columns. Number of columns equals number of rows. Ulta you see, number of columns is equal to number of rows. So both are existing, and AB, if you're multiplying, 3 and 3 are same. So you have to get a 2 cross 2 matrix. We got 2 cross 2 matrix, 2 rows, 2 columns. If you're multiplying it in a reverse way, then 2 and 2 will be same. 3 cross 3 matrix you have to get. Order itself is different. By here itself you can say that AB is not equal to BA, but still they have multiplied this particular row, then this particular column. 2 ones are 2, 4 threes are 12, add those both because minus sign is the minus. Similarly, again this row, this column, then again this row, this column. If you we keep on doing in that way, you will get a 3 cross 3 matrix. Obviously order is not same, how will there be equal matrices? So AB is not equal to BA. AB and BA could be same if they were of the same order, but it is not so. Here we give an example. If they are of same order, will there be same or not? Because here we are saying they both are of different order, so that's why maybe AB is not equal to BA. Okay, but let us check if what if they are of same order. A and B are of same order. So then AB will be what? Consider this row, then this column. 1 zeros are 0 plus 0 ones are 0. So this element is 0. Then again this row, this column. Like that if you multiplied, you got this. BA also you can multiply. Again, if they both are square matrix, if they both are having same order, BA will already exist. You know that. Again, you have to take this row and this column while multiplying BA. Now, if you see AB and BA, they are having same order, but are they equal? No, they are not equal. So, no matter if A and B are having same order, if they're having different order, whatever the scenario may be, AB is like you cannot say that if order is same, AB will be equal to BA. If order is not same, it won't be equal to BA. It completely depends upon the kind of matrix and the kind of elements you are having. So just by looking that they both are of same order, you cannot say AB is equal to BA. We have to check it in this manner. So it's not commutative. Generally, in our number system, multiplication is commutative. 3 into 2 or 2 into 3, it will be the same. But matrix multiplication is not. AB might be there, BA might not even exist. If BA is existing also, it might not be equal to AB. So that is why. Now, this does not mean that it is not equal to every pair. Like here in this example, if you multiply, both of them are getting same answer. So observe the multiplication of diagonal matrices of same order, that will be commutative. So if you have to find out where AB and BA is exactly equal, then you have to have diagonal matrices and same order. Basically square matrix and same order will give that BA is defined, and diagonal matrix meaning except the diagonal elements, every other element should be 0. These are the diagonal elements and every other element is 0. If you're able to find such kind of a scenario, then it is obvious that AB and BA will be equal. Now one more interesting point, zero matrix is the product of two non-zero matrices. Generally, if some numbers are there, like A and B, some numbers are there, if you multiply you're getting 0, then you say either A is 0, either B is 0, or both of them are 0. This is the common thing we have been doing. In matrices also, can I say that? Matrix A is there, matrix B is there. If I'm getting a null matrix, either A should be 0 matrix or B should be 0 matrix, or both of them should be 0 matrix. Is that only the case? No. If they either of them are 0 matrices also, you can get a 0 matrix. That's what they've given. Here A is not a null matrix, all the elements are not 0. B is not a null matrix, all the elements are not 0. Multiply them and check. This row and this column, 0 into 3 is 0, then plus minus 1 into 0 is 0. 0 into 5 minus 1 into 0, that also gives 0. 0 into 3, 2 into 0, that is also giving 0. 0 into 5, 2 into 0, that is also giving 0. Null matrix you're getting, either of them is not a 0 matrix. So it is not necessary. If you see AB is equal to null matrix, it is not necessary that A is a 0 matrix or B is a 0 matrix. Remember that point. Now, properties just like we have seen in addition. Let's see over here. Associative law. Now in brackets. Commutative though it's not there. General cases. If they're diagonal matrix, then same order, then maybe equal. So AB into C, you can multiply these two matrices and then multiply C. Otherwise, multiply BC and then A. Now, whenever both of the equality are defined, again this is like a special case only, because you have to check no after first of all A and B, their columns, their rows should be equal. Then after multiplying and taking one more new matrix into C, the number of columns, number of rows should be equal. So these conditions are there, isn't it? So when the conditions are satisfied, then you can say these both are equal. And here also, if your distributive law is there, general, like in numbers also, you can either add two matrix and then multiply with another matrix, or multiply this matrix with this, then this matrix with this, and take the sum of it. Again, remember, the columns and rows condition should be applied everywhere. Now, multiplicative identity. This is nothing but identity matrix. Remember, in our previous session, we learned about different types of matrices, and there we learned about the identity matrix. Identity matrix is nothing but represented by I, and where it's a diagonal matrix, so only diagonal elements should be there, other elements should be 0, and the diagonal element should be 1. So 1 0 0 1. This is identity matrix, because these are diagonal elements, except for that everything else is 0 and the diagonal element should be 1. Now this is multiplicative identity. Why is that so? Because you take any matrix and multiply it with I, that will be equal to A into I, that is equal to A itself. This is a very important property we'll be using in several questions. So remember this, A into I can be written just as A itself. We can take an example and see. So we can consider A as any matrix. Suppose let us consider this is a 2 cross 2 matrix. Now let me take an identity matrix. Again, while multiplication, ensure that column and row should be equal. So let me take of same order only. 1 0 0 1. This is also 2 cross 2 matrix. This column is equal to this row, so I can multiply. If I multiply, I have to get A itself. A I. Okay. So let's go row by column. 2 into 1 is 2. Plus what? 4 into 0, that is 0, so no need to add it. 2 into 0 is 0. 0 plus 4 into 1 is 4. 0 plus 4 is 4. 6 into 1 is 6. Plus 2 into 0 is 0. 6 plus 0 is 6. 6 into 0 is 0. 0 plus 2 into 1 is 2. So 0 plus 2 is 2. What did we get? After multiplying A and I, we are getting A itself. So remember, when in number systems, like if I take any number like 3 and I multiply it with 1, then I used to get 3 itself. Same kind of scenario, just it is a matrix multiplication. So this is one was called the multiplicative identity. So here I will be called the multiplicative identity. That's it. And inverse is also there, which we will learn later on. Here we are not learning about it because inverse is slightly different. So now what are they telling? They have given A, B, C matrices. Basically, like we are trying to justify or prove these laws. So I'm telling A into BC we are finding, then AB into C we are finding. So we have to prove that these both are equal. So they are defined and we have to prove that they are equal, the associative law. So again, simple. A into B, you see how many columns are there? 3 columns and 3 rows are there. You will be able to multiply first row with first column, then first row with second column, add the elements, find the elements. Then after multiplying AB, they have got this particular matrix after multiplication. Now AB into C they told. After multiplying AB, this matrix we got, and C, this is what is given. Now again see, is this scenario defined? How many columns we have over here? 2 columns. How many rows we have? 2 rows. So we can multiply, yes, this row with this column, this row with second column, then third column, then fourth column. We are getting this matrix. Okay, we got this matrix. So AB into C, this one we got now. A into BC. So first multiply BC now. They are multiplying BC now. Again over here, two columns, two rows, so we will be able to multiply it because multiplication is defined. First row, first column, first row, second column. After multiplying BC, we got this. Now we have to multiply it with A. Put this over here, A to the front, again multiply it. We are getting the same matrix. Here also same matrix, here also same matrix. So associative law is uh, proved. Now a question is given, same sort of question. We are proving the distributive property over here. A, B, C is given. They're telling us to find what is AC and BC, then A plus B into C, so that we'll be able to prove this. Okay, first we will see the LHS side. Add these both corresponding elements. You can add because here what is happening, same order is there. For addition, same order should be there. Here also 3 cross 3, here also 3 cross 3. 0 plus 0, 6 plus 1, 7 plus 1, minus 6 plus 1. They have did, they got this. A plus B into C. Take this matrix, then multiply it into C. So again here we are having 3 columns, 3 rows. You will be able to multiply 0 into 2, 7 into minus 2, 8 into 3. Now there is no one more column to go, so just leave it like that. You're only getting like one element over here. Go to second row, then again that same column. Third row, then again that same column. Because more number of columns are there, I can't multiply anything else and get the second element in the first row itself. So this is what we are getting. Now take this. We got the LHS. Let us consider RHS. AC we will multiply. Same rule again. BC will multiply. Now we have to add this both. 9 plus 1 is 10. 12 plus 8 is 20. 30 minus 2 is 28. Same matrices we are getting. So distributive is also proved. Now these are very important kind of questions. A cube they are asking. So first we will multiply A into A to get A square. Don't directly cube one element over here, 1 cube, 2 cube, 3 cube. Don't do that mistake over here. You have to multiply A into A, then again into A to get A cube. So first let us find A square. Again basically same order, so you can multiply 1 into 1, 2 into 3, 3 into 4. So 12 plus 6 plus 1, that will be the first element. Then again this row into this column, this row into this column, like that we are multiplying, and we got one matrix. Now this is A square. To get A cube, multiply A square with A. Multiply A square with A. So take this and again take A. Again we'll multiply. One column by one row by one column, one row by one column. We'll get this matrix. We got A cube now. Minus 23 into A. So again scalar multiplication, just take minus 23 as a number and multiply with each element. We will get this minus 23 into 1, minus 23 into 2, like that. Minus 40 into I. I is nothing but identity matrix, and generally either they will mention saying that okay, I is a 3 cross 3 matrix, otherwise you have to take according to the rule. Over here I took 2 cross 2 because I have to multiply and show over here. Not always 2 cross 2. You can take 3 cross 3. You have to take 3 cross 3 here because eventually you're going to add all these 3 matrices. If you have to add, all the orders of the matrices should be same. This is also 3 cross 3. This is also 3 cross 3. Then what should this be? 3 cross 3. So take the diagonal elements as 1 and non-diagonal elements as 0. Multiply with minus 40 and simply add. Now corresponding elements you can add. 63 minus 23 minus 40. That will be the first element. Then for the second element, 46 minus 46 plus 0. Like that, all the elements you add, you're getting a null matrix. That's what they asked you to prove. Show that this is a null matrix. So like this kind of proof kind of questions can come, or they might not give this and tell you to find directly. You will be able to find. You will be seeing these kind of questions in exercise also. We will solve that time also. Now one more example question is given that in a legislative assembly election, a political group hired a public relations firm to promote its candidate in 3 ways. So telephone, house calls, letters they have given. The cost per contact is given. So per contact the cost is given for telephone, house call and letter. In form of matrix it is being given. Now there are 2 cities it seems, X and Y city, and how many contacts are there? 1000. So per contact 40 rupees, but here 1000 contacts are given. Then for house call there are 500, 5000. Generally in these kind of question, if we have to find the total amount spent, what we used to do? Like the questions used to be like, one contact is for 40 rupees, then 1000 contacts, how much will it cost? We used to multiply. Here also same thing, but because it's a matrix, we'll be doing matrix multiplication. So that's what they have done over here. We are doing b into a. So it is important to find how we have to multiply. We can't multiply a into b, because we used to be like, if one thing is costing 40, then 1000, how much will it cost? Meaning 1000 into 40 we used to do. So b into a you have to do, keep in mind, because here it's not a commutative property, you can multiply anything in any order. So take b into a, and we are considering, take this as one particular matrix. X has only this one row, and this is as one column. So over here, if you see only this top part, we are having one row and three columns. Here we are having three rows. So order, according to this, the columns, number of columns equals number of rows over here, three columns and three rows. So multiply this 1000 into 40, then plus 500 into 100, then plus 5000 into 50. That's what they have done over here. Add everything, you'll get for X. Now do for Y, same thing. Y as this one particular row you consider it, so that you will be able to multiply 3000 into 40, 1000 into 100, 10,000 into 50. Add all those, you will get Y. So this is the amount of, that is a total amount spent by city X and city Y. So that's all we have covered. Entire addition, then scalar multiplication, then multiplication and type of questions we will be getting to do. In the next session, I will take this exercise 3.2. If you have any doubts and any sorts of problems you want me to solve, please feel free to leave a comment in the comment section. And if you like my way of explanation, please like this video and subscribe guys. See you in the next video. Bye.